All right, part 4 is the definition of a logarithm. The first couple questions here, 1 and 2, should be simple. You're just using the definition, which we used in the multiple choice part. So here we have log base 5 of 625 equals 4. I'm writing this in equivalent exponential form. This is what we use that curly Q method for. You always start with the base of 5. Remember, the logarithm gives you the exponent, so that answer of 4 is the exponent on 5 equals 625. That's all you're doing here. So same thing in B. Follow my curly Q. 1/2 to the negative 5th power equals 32. For this bottom one, I have a common log of 1,000. Remember, the base of the common log is 10, and that says 10 to the 3rd equals 1,000. Finally, I have a natural log. The base of the natural log is e, and if I follow my same pattern, e to the 0 equals 1. Now I'm just doing the same kind of thing, but the other way around for number 2. I'm turning these exponentials into equivalent logarithmic form. I still start with the base, and then I'll loop around towards my equals. So I have a log base 6 of 216, that's the second number, equals the exponent of 3. Remember, what the logarithm equals is always the exponent. Same idea here in B. Log base 19 of 361 equals 2. For C, log base A of M equals G. And finally in D, I have log base 10. Now, if you write the little log base 10, that's okay. But for the common log, we typically don't write the 10. So log of 100, 1 over 100, I'm sorry, is negative 2. You could squeeze a little base 10 in there if you wanted. All right, last question for this part is graphing a logarithm and an exponential. So we're going to start by graphing f of x equals 1/2 to the x. I would use your graphing calculator to build a table. Okay. Build your table here, and it says starting from -4. So I would plot -4. You can hit pause if you need to, or use your calculator. Type all those x values into from -4 to 2 into your paper. So let's see. So we'll have 16. Okay, and then I'm going to plot those points. I'm going to use black for all this. So -4, 16, I'll estimate there. -3, 8. -2, 4, -1, 2, 0, 1, 1, 1/2. There we go. So as I connect those, remember the points keep going. They get really close to that y-axis. That is the asymptote, which is the box right underneath. So the asymptote for that graph f of x, remember that's at the x-axis, or y equals 0. Now when I graph the inverse, all I need to do is switch the x and the y's, because the inverse, we learned a couple units ago, is the opposite. We flip the x and the y values. So all those y values there become x's, and the x's become y's. And you can plot all those points. So I'll have 16, -4, right around there, 8, -3, 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4. So I should see the same kind of shape here for f inverse. All right, now the asymptote for the inverse function is on the y-axis, which is x equals 0. You should remember that all inverses reflect over the line y equals x, which I'm just going to roughly sketch right here. That line, and you can see they do reflect over that green line. The inverse, let's say it again so we don't forget, the inverse f of x here, that pink graph. Remember, f of x was an exponential, this box right here. That's an exponential function. The pink graph is its inverse, and the inverse of an exponential is called a logarithm. It's going to be important for the next part of the review.